Hello, circular motion basic template itai tawin to hi second part hi circular motion acceleration force ti ho na if it di hutantin force to acceleration abon ke he video khana simni katia la chun hong sao thimen na so sao sanga cho ni akan hop handing din to hi he chipe na hi acceleration hoi sim dio abana pan pen ho force hoi sim dio Okay, so let's continue. Suppose a body is undergoing a circular motion. Chu XY plane ahi body khari circular motion perform. So, hezi body pahi. So let's say at a particular instant, hilai umda sa point P ahi umna jalahi. Chalai point P coordinate he zat diha. Suppose it makes an angle theta with the x-axis. Na P pa coordinate he zat diham. Radius R la leo chun na chipai R la leo chun chipen hi R cos theta R sin theta hile chun na coordinate pa he tang hui itung kun na chipai so if I take a vector here na chilang pa he pya so the side which contains the angle will have cos theta na cos theta chu x lang pa chula okay so R cos theta chipa chu x pa x coordinate abana chung langa y coordinate pa chu sin theta hi ngai na R sin theta okay chu coordinate hesa khotile hin circular motion ahe na quantities hoi hlang pi ahi abon ahi so they will either be so along the radius okay along the radius or they will be along the tangent direction ni hina unit direction ni specify ngai cho physics ahi direction khat ke ti hina iti ki so de ha example chu x axis langa hi force vector khat achiala chun chu I ke bi tiu chula na khutile y axis langa hi vector khara chela chu z ke bi tiu chula na khutile chun tu hin vector khar hi chilanga chila hin hi chi zat iti na represent diu kha chu so let's try to create a unit vector na I hon ga ke sim do da a unit vector khan so that when any vector is along this side okay suppose r vector is along this side the r ki vector khar hi chilanga chila chun hi chilanga chi ti na chuna hi thine so chila let's say e r cap na hi chi er cap in p va sanam tere hi chi r vector pa hi chilang kai hi chilang direction hi chi hi tina na matang 3 I cap ka zia la chun hi chi chu along the axis hi 3 unit vector khar chi ki ti chula na japan hin so like that jeta pa chu unit vector khat chu one unit vector along the radial direction another unit vector along the tangential direction okay na kasi bang chu unit vector hi physics a he direction point nothing a chu na ke bang ji za chi chu radial direction khat hi er cap tiu den tangent direction khat hi e t cap tiu da okay khotele er cap hi tin ji de ha so how to write er cap so er cap is batang displacement vector ibol jula na so if any vector is along this side I have to write the final minus initial chu zat ha origin chu 0,0 na khotel r cos theta minus 0 I cap r sin theta minus 0 z cap chu r bar chula na japan here khotel e cap jong so similarly I can write here so cos theta minus 0 to head direction because it's a vector r zawlo so cos theta I cap plus sin theta z cap okay so this is a unit vector along the radius and outwards okay along the radial heda bana chu outward direction na chu er cap tin chu okay so er cap is a unit vector along the radial and outward direction khutela chun suppose I have a force here na force kha chu chalanga ko chun now I can write suppose if the force is F so I can write here the force er cap na chin pi ba sa ha I have a vector whose magnitude is F and it is along the radial outward direction okay to chi ta bang chu et pa khoi ti ji ha so how will you write the e cap et cap chi ta bang chu bata so if I write here along this side na batang vector kha chu chalaya ma la chun along with the x-axis angle pa he velocity ki bang so na angle of obtain pa he subtend pa he chichu ki hilowa vector magnitude pa hela say this is x so this is also x so vector ni chu ti phar ki bang de ha magnitude ki ba direction ki ba la chun na amani chu ki bang so this is the reason why you can slide vectors hilanga vector khalum chu hilang ka tol phaya la chun na without changing how much angle it's obtained with the x-axis. Okay, without changing the angle, without changing the magnitude. Suppose I have 10 here. I can slide the vector. Okay, so the vector will still be the same. Suppose radius r point pa hi q ti q pa coordinate hezat de ha q pa hi r batang hi theta chulana theta hela chun pa hezat de ha pa jong theta hi ngai na hi 90 minus theta. Okay, perpendicular heza sum chu 90 hong hi ngai na chun pa jong hi theta hi ngai cha hi theta coordinate q hi zetin ji do ha. So x2 to hi angle pa hi y langam ta chana hi cos theta pa hi. So theta lies on the y axis. So on the y axis I will have cos, on the x axis I will have sine. Q to r sine theta, r cos theta. Okay, hi e t cap kan ji ta chu e t cap chu sine theta minus 0 x-axis negative x-axis to minus r. Okay, minus r is abana chu e t cap e t cap chu so minus sine theta I cap. Okay, plus cos theta j cap. Okay, so this is a unit vector along the tangent. Yeah, so this is a unit vector along the tangent. Okay. Nah, so E r cap to a unit vector along the radius outward direction. Abana E t to unit vector along the tangent. To a vector point a unit vector ni na E r to E t. So if any quantity, for example, acceleration hi charang ji jana hi. So now I can write a E t cap. So that means acceleration is along the tangent. Okay. Okay. Next, chalai P pa hi na body P pa hi. A position hi vile hen to hi r cos theta to r sin theta chole na je position vector ga ji le hen iti dem position vector chu r bar ti le na r bar chu r cos theta I cap plus r sin theta j cap chole na position vector of the body. Abana chala hi velocity ko hol do mane na velocity ko hol do mane bika bol hai. So here I have to differentiate r. Position to differentiate velocity hung pod chalana. Okay, so let's differentiate that. So here r2 I'll write here r2 r cos theta I cap plus r sin theta j cap na. V is equals to dr by dt. So here so ke chulana r pa achunga pa differentiate bola chun r chu constant is r cos theta differentiation jo pe ham so minus sin theta. Okay, so d theta by dt I cap na plus r into sin theta differentiation jo cos theta d theta by dt. Okay, into j cap na differentiation ki bol cha. Okay, common se pp ham r common na d theta by dt common na. Abana so remaining to be minus sin theta I cap plus cos theta j cap. Okay, chihi piha chihi velocity. Okay, abana chila he velo chun batang v is equals to r into d theta by dt chupita omega chale na last video bol ba cha. So r omega abana he chila ya he chi vector pa he pita chi. So minus sin plus cos chupita. So minus sin plus cos chu he chi pa he. So E t pa hai na. So now I can write V equals to R omega E t cap. Chihi biha chi velocity. Na circular motion velocity chu chi. So V equals to R into omega omega into R na E t cap ki chu chi along the tangent. Tangent na. But the velocity of any body undergoing circular motion, a velocity jo hilang am dia always along the tangent. Okay, depends on melzi le chun abale but v equals to omega into r hung kon na chuna chila hi chu chila hi. Last video jong bol chala na. So v equals to omega into r helole omega equals to v by r bol pen chuna chi ang pod na cha. Okay, abana hi v mo wala chun acceleration ki va na hotel acceleration bol na ding chu. So now let's write the v again. Okay, I'll write in the next page. So v equals to r into d theta by dt. Okay, minus sin theta I cap plus cos theta z cap. Thì cho là v cho. Okay, khut le chila hi a chu pita a chu dv by dt cho là a chu. Khut le v pa hi available differentiate bol ke le chun. Dang he chi function zan ma la hi. Chai function khat ma, chai function khat na. Ni khat te khon. Maths f of x, z of x differentiation chu pi ha. Masa pena cho first function cho hidan dan koi dio. Okay, and then differentiate the second function. Na plus abana first differentiate the first function and keep the second function as it is. Hit the bang khat jana na maths differentiation na cho. So use that one. Masa pena cho differentiate bol bilang chi dan koi bilang na. Abana chu hit pa differentiate bol bilang hit pa dan koi bilang chi pa differentiate bol chon. So what will you get? Okay, first r into d theta by dt cho omega cho pi ha. Okay, tin omega zo to chala r omega na. Ko tele ka difference da chun d omega by dt hung po cho chala hin. So sin theta plus cos theta z cap na. Plus to hi first function cho om dan ko ding, second function cho ka differentiate kid de. Ko tele minus sin theta differentiation cho cos theta na into d theta by dt. So this is I cap. And then cos theta differentiation to minus sin theta. Okay, so d theta by dt. Okay, I'll write here. Minus sin theta d theta by dt z cap. Okay. Right, so the differentiation ta na ho dilaga so to leuhen r into d omega by dt. He chila hi minus sin theta healthy majam na I plus cos theta z cap. Chila d omega by dt hi pita. Alpha hello na masai boljo angular acceleration. Alpha cho d omega by dt hi la chun chila hi. So I can write r into alpha. Okay. So abana second equation ha vela chun minus to minus na minus to polang la do leo chun. So minus r omega into so d theta by dt ang common na both side. So d theta by dt remaining to be ha cos theta I cap plus sin theta z cap. Right? Khutila chalai pan himvela chun ipipita. So alpha r into alpha hi chalai minus sin plus cos hipita. Azo bolo chu. So minus sin cos sin plus cos chu et chula na et cap. Okay. So minus r into betang chalai d theta by dt hi omega chula na omega into omega chu omega square. So r into omega square asunga ko pima cos plus sin chupita er chula na along the radial path chu. So this is er cap. Okay, so this is acceleration. Circular motion acceleration chu chalai derive do pau hena chi hi ga phaten ga value chun ipima chalai direction nium chana. So that means there are two acceleration in circular motion. Okay, circular motion acceleration nium ding, one is along the tangent, another is along the radial. Na chalai hi tang themat ga thaji diuleng lai hi. I can write this as alpha into r et cap plus omega square r into minus er cap. Okay, so this is the acceleration of circular motion. Chichu piham kasi bang acceleration nium na khatpen chu along the tangent heading khatpen chu chila have the minus er vector so minus ahung mal chun opposite cho aso er chu piha er chu a unit vector radially outward kiti chuna je ai bang chu chala minus ki koyala chun direction chu hoilang de ha it should be radially inwards. Okay, acceleration khatpa chu inward direction am ding khatpa chu along the tangent am de na chi chi achu hi chi pen hi bigidia. So the first one we call this as tangential acceleration. Okay, at ani na pa hi, so it is along the radius, so we call this as a radial acceleration. So in a circular motion you have two acceleration. So one is radially inward towards the center chipa chu kita radial acceleration kiti na, and the other is along the tangent chipa chu tangential acceleration kiti cho. Abana chu atile Isla in Chumile Gazile, a tangential to a tangential to alpha into r. So this is et cap. That means along the tangent. Na chipa hi tangential acceleration kitia khatpa chu radial acceleration. So omega square r ahilole omega chu pi ha v by r chula na tu in omega hial hin v by r koi lo chun so v by r square into r chu that ha so v square divided by r okay er chuna omega square into r hilo le v square by r ta long ji thei cho chi chi pa hoi lang ha so radially inwards towards the center na chi pa so we have two acceleration. So one is along the tangent, another is towards the center along the radial direction na. Khutile amani ka hai na, hui chipen hi 0 ai them. So do you think you it's a tangential pa hai 0 ai them, I like radial pa hai 0 ai them. See circular motion pa ko na diagram ka draw le hai ni ta hem cho. Khutile at any point, so at this point khad chu tangent langa chu acceleration na che pa at okay khad pa chu inwards a chu ar na chela he khotile batang at chu pi ha at chu alpha into r tu chona che alpha he pi ha d omega by dt chula na che he into r. So what happens if omega is constant? Omega ki khel wala chon pitir ha d omega by dt ho za deta, so it will become 0. Okay, khutile alpha to 0 ti nei chula na alpha to 0 hila chun at chu zat de ha so at becomes 0. Okay, so that means the tangential acceleration can be 0. Okay, 0 he dai cho na chi at pa he chi at pa he 0 hila chun so azo phale tha chuma ka ji le hoina chi pa he this is the condition for uniform circular motion. Okay, speed constant only pala khonna speed constant hi pala chun, so that means if omega is constant then you're going to have d omega by dt is 0, so that means your at will become 0 chu uniform circular motion adinga condition khacha, so that means at can be 0. Okay, khotele what about ar pa has 0 ai them betang hita hi force khat chi chona for hita hi particle khat chi so if there is a force applied on this side veilang kaya son khat am chun a path chu ti chi ha tai koi chona chi koi ne. Okay, so that means sakuna che pi head over, so ar is responsible for the direction change. Circular motion kha hi thene dinga chu direction a change jingai chola na ta hi ko ya tai direction change a ngai chola jang pet lo pu chila chila hi tu chun force lo in body kha chu jang ken chila chun hi tai straight path chona japan hi force ahung pha le bo chun some acceleration thempat ahung pha le bo chun particle path pa ta hum koi de cho. Okay, he chi a koi na ji pa he na he chi koi na ji pa direction ke change na ji pa hi pg ham tele ar ji cho tu hin ar hi ta hi le pi tire, so now the particle will start moving in a straight line. Okay, uniform circular motion ke ti ta ta cho. Okay, so that means for a circular motion ar is necessary. Okay, it is required te ngai na, so therefore just remember ar pa hi 0 hi tai lo. Okay, it can never be 0. Okay, remember that. So acceleration nium la chu at pa chu 0 thading a 0 ahung hi ala chun che chu uniform circular motion ke ti na 0 hi lo la chun che non uniform circular motion ke ti cho abana ar pa hi che pa hi 0 he tai lo de, so it can never be 0. Okay, so remember those 2 points. Aban le acceleration te ni hi kha chu radial langa ma kha chu chelanga ma chun net chu hilanga am de ha acceleration te ni anya vector chula na, so both of these are vector. Okay, if you want you can put a bar here. Kutila a resultant chu hilanga am de ha, so somewhere along this side, so a net. Okay, magnitude of a net chu ting pot diam betang at to a r pa mani ka angle hi zat ha, so they are perpendicular na as you tangent ki ti pha po chu radius to perpendicular chula, so both of them are perpendicular. Chija chu net acceleration chu zat ni ha a net will be given by the magnitude of a net will be given by so ar square plus at square, magnitude of ar square plus magnitude of at square. Question abang lakon net acceleration ki tong ji na net acceleration ki do ala chun formula chu, so this is the formula. Okay, okay, so far pp bolota velocity bolona velocity direction jong chone hero chula na bedang chela hinga jiute khabe things in ta he particle kha chu circular motion achi ala chun ma sapena chu velocity chu hedang am ne ha, so along the tangent. Okay, so this is v, so which is what r into omega na et k cap. Okay, along the tangent abana chu acceleration jong nium na kha chu along the tangent, that means it depends to at hi za chu alpha into r. Okay, along the tangent abana khat pa chu along the radius chu ar. na AR pa hi zat ha AR equals to V square by R a hi lo le omega square into R na je pen hi along the minus ER cap okay towards the center aban le additional point khat na chelanga radial acceleration ti pau hi betang towards the center chulana a direction chu towards the center hi ja chu min tha khat ki pi chu chu bhem tele that sometimes it is also called centripetal acceleration okay so radial pa hi na so this radial is also known as centripetal acceleration chichu bija ki pm tele center direction towards the center a chi ja chu na he chi ja chu centripetal ki ti chu a pen he so you can remember that one okay khotile to hi uniform to non uniform as well as pen so na thempat point ga 11 uniform circular motion chu di phalam de ha batang okay I'll just write here circular motion particle hi velocity hi changam chana je so this is the velocity okay towards the tangent magnitude of velocity chu bia speed ki ti chuna je he khotele batang speed chu constant ong hiala chun so if speed is constant okay he chu iti ka ji di ha so speed is constant v is equals to omega into r chulana je magnitude pa chu he je pa constant hi la chun radius chu constant za omega jong constant hi ngai na okay so you can say omega is constant okay alang pe chu speed is constant it is user aji chu velocity batang ibolai lai velocity is constant ki telo ha velocity ki chu vector chulana a direction pa he velo chun velocity direction ki khial jing ke beta he chi chilai pa he velocity changa ko na tun chilang hung le chun chilanga ko ke cho so if you are here you will point along this side okay this is velocity so velocity keeps on changing okay ai wanga a value pa chu na velocity magnitude pa chu speed ki ti ja he che magnitude pa chu keep a constant here la chun ita hi uniformly ata hi ki rotate le chu okay it will rotate uniformly like this just a speed constant here la chun so there you will have so d omega by dt is constant will be 0 okay na speed constant here chun omega jong su constant ni cho ji jo ka se ban so v equals to omega r na chang so chilai kun an so the reference na theo okay so that means here alpha will be 0 so that means at becomes 0 okay at chu phi alpha into r has alpha 0 here chun at chu 0 okay so the tangential acceleration is 0 in a uniform circular motion na uniform circular motion acho speed is constant okay so remember only that point speed constant hi lawa batang okay speed constant hi na uniform circular motion ading condition chu piha at is equals to 0 na ma sapena chu er cannot be 0 okay so we have lang abana chu at chu 0 hi lawa er jong 0 hi law la chun hi je pen hi piha je pen hi non uniform circular motion okay non uniform ti na chu okay khote chain ke ding in azwa velocity acceleration direction hoy na I'll write it like this xy let's take 4 points okay so point A point B point C to point D na khutile point A ko speed hoilanga chiam speed chu chilanga chi na suppose if the whole thing is moving anti-clockwise okay anti-clockwise circular motion achi ala chun v pa hi chi na b a ko v hoilanga left lang na chala hi awana c a ko hoilanga downwards okay aji chu v chu along the tangent of moving ke ngai jana d a hi v hoilanga chilanga hai na so this is v so that means you can see that the direction of speed velocity is always changing okay ani na chu acceleration tangential pa chu he che he na at okay achunga jong b a jong hi tangential chu chilanga am ding okay c a hi tangential hoilanga chilanga he na at abana d a jong ho tangential chu chilanga hi na chilai ko na thil khan he te chu pi ha so this acceleration is responsible for the changing value of speed okay chilanga hi acceleration chilanga ya mal chun speed chu ki khial de na chu okay so here if the speed is changing if the speed is not constant it is a non-uniform circular motion na non-uniform chu ipg ham de la speed chu ki khel constant hi lo je na speed chu ibola constant hi lo ham de la at om je ai okay at is in this direction abana chu ar chu hilang ha ar chu always towards the center okay ar chu hi za So AR is this. Okay, so like this. Na lang bikat direction ho chu acceleration to velocity direction chu. Okay. Hotele to I say so bon jang kaya chu. Let's do a summary. Quick summary. Circular motion has two types of acceleration. Radial, tangential. Radial AR it is always towards the center. Okay. So this component of acceleration is responsible for changing velocity direction. Kasi banga na hidia particle force AR malchun, so it is now going like this. Okay. Koi ta chula na chi velocity chu always along the tangent ja. Hichi koi ja velocity pa jang direction ki hial. So it is also known as centripetal acceleration as it towards the center so radial acceleration mass is a mass to require now it cannot be zero. Okay, formula omega square r v square by r. Okay, radial acceleration is tangential along the tangent. Okay, or along the velocity along the velocity opposite to velocity example rotation agan acceleration along the velocity okay rotation ahung all so it means that the velocity is along this side and the acceleration is opposite. Okay, that means there is deceleration retardation it is okay, abana component of acceleration is tangential it is responsible for changing magnitude of speed. Okay, magnitude of velocity speed okay, if speed is constant then omega is constant. Okay, so that is omega is constant d omega by dt is 0 alpha is 0 alpha to 0 tangential acceleration 0 hongide. Okay, so that is the condition for uniform circular motion. Okay, at alpha into r, alpha to at by r. Okay, theory okay, so that much is theory. Force part centripetal force, centrifugal force lecture okay, so now let's solve some questions. So first question, an object follows a curved path, so the following quantities may remain constant. Which is constant okay, may remain constant during the motion. Must happen as a speed constant velocity to constant velocity to okay, when you rotate, so the velocity is always changing. Okay, like this. As a diagram I draw here. So that means B is wrong. Abana acceleration acceleration is also changing radial path thing. So AR is like this. Okay, AR is like this. Like this. Abana along the speed. Okay, so that means acceleration cannot be constant. Abana magnitude of acceleration to constant magnitude kiti acceleration 1 meter per second so there is acceleration. Okay, the speed is not constant here, but the magnitude can be constant. 1 meter per second constant so the fourth option is also correct. Okay, so that means A and D. A particle moving in a uniform speed kiti constant speed to uniform circular motion kiti uniform circular motion possible constant velocity to constant acceleration constant direction is constant velocity constant so varying velocity, varying acceleration. Okay, so this is correct. Medical exam 2024 question. A particle moves in a circle of radius 1 centimeter at a given speed v2 pkpm v2 2t function kipi speed so v is given in terms of function, so where pkp so centimeter per second kiti so keep in mind find the radial acceleration of the particle at t equals to 1. Radial acceleration formula pitam. So A equals to V square divided by R. At T equals to 1. T equals to 1 achu V choose 1 put 2 centimeter per second. Okay, so this is V. Formula put A choose so 2 into centimeter to 10 power minus 2 whole square. So divided by R to 1 centimeter. 1 into 10 power minus 2. solve the change for them. 2 to r 4 into 10 power minus 4 divided by, so 10 power minus 2. So 10 power minus 2, so minus 4 plus 2. So you have 4 into 10 power minus 2 centimeter per meter per second square. Okay. 4 into 10 power minus 2 to centimeter. So I can write this as 4 centimeter per second square. Okay. B to tangential acceleration at t equals to 1. Butang tangential acceleration at t to pita. Butang velocity to na velocity to speed to butang magnitude of velocity to speed to na speed pa to kui mo po na ha at pa mo po na chuna. Tangential acceleration is responsible for the speed, okay, and radial is responsible for the velocity direction, okay. Kutel radial pa direction responsible alajun tangential pa speed magnitude pa responsible na. Kutel speed ki pa he differentiate bolajun tangential pa ang pot dacho. Okay, so therefore here at is what? So dv by dt. Speed pa na differentiate bolajun at hung pot. So that means what is that? 2t who differentiates in who? So 2. Okay, so that is the answer. So 2 centimeter per second square. Na chila kasi itan him d mod of v to speed katina ito. So ita he dv by dt kasi asun sipen hi velocity katina na. So dv katiazun. So this is speed. Okay. Kutila third option so piha. So find the magnitude of acceleration at t equals to 1. Magnitude of acceleration, net acceleration. So a net is what? So magnitude is ar square. So ar na. Ar square plus at square root. So ar to 4 square plus at to 2 square. So 4 are 16, 2 are 4 under root to root 20 centimeter per second square. Okay, so net acceleration na. Okay, next, a man carrying a monkey on his shoulder, thus cycling smoothly on a circular track of radius 9. Radius should be 9 meter. So completes 120 revolution in 3 minutes. Okay, so something is given here. Question centripetal acceleration AR AR so we have v square divided by r. Okay. V square divided by r. Kutila v chuki hem v chuki hello na radius chuki he kutila v hold do dine. So here see vitang 3 minutes should be ha. So 3 minutes means so 3 into 60 seconds. Okay. So that means so in 3 into 60 seconds, so that means 3 6 are 18. Okay, in 180 seconds, is that way revolution complete na 120 revolution. Okay. Now hotelation in 1 second. Okay, 1 second. How many revolution? 120 divided by 180 revolution. Okay. As you ipola 1 second ka holam tela per second. Velocity chopi ha distance covered per second. So na distance by speed, distance by time. So distance covered in 1 second, that is velocity. Okay, or you can say speed. Kutila chila hemta revolution his at kivialman. So the distance ko holanga so na distance. So see in 1 revolution. Okay, in 1 revolution distance covered so that ha 2 pi r so na 1 revolution acho. Kutila 120 by 180 revolution acho. Distance covered so that ham 2 pi r into 120 divided by 180. Hule chunjan ponam 6 2 are 12, 6 3 are 18. So that means 4 pi r divided by 3. See distance tacho. Hutela speed to distance by time na distance per unit time so is that ha. So this 4 pi r by 3 divided by 1 second to speed tacho. Okay. So therefore, the speed is what? 4 pi r by 3 by 1 na. So this is the speed. Kutila acceleration iti hold. So therefore, AR is equals to so v square 4 pi r into 4 pi r. Okay, square divided by so 3 into radius to 9. Value po 4 pi into 4 pi so 16 pi square na. Radius to 9 into 9. Okay. So divided by 3 are 9 into 9. So 9 cancel out. Final answer is that 16 pi square meter per second square. Okay, option that option B. Okay. An object moves at a constant speed along a circular path in a horizontal plane. center at the origin kiti chu na. So it is like this. Circular para ta chi chu hotele pikipia when object is at x equals to 2 plus 2. So at 2, 0. Okay, velocity chu hilang ham 4 minus z na minus z chu hilang ha downwards achi. So this is v. Okay, v is minus 4 meter per second minus z cap. Okay, abanan sa object's velocity and acceleration at x equals to minus 2. Kutile minus 2, 0 ahi velocity chu hilang am de ha. So it should be along the tangent na. Motion chu velo hen. Batang sila v equals to minus 4 I z cap ahi minus 4 minus z cap apa he thayu chu pi particle is going, object is moving anti-clockwise, clockwise direction na ita hi. Kutile v chu achung lang time da chu jahi. So this is what 4 plus z cap. Okay, v should be plus 4 z cap na towards the positive y axis chu. Kutile out of the option, so c and d are wrong. Okay, abanan so acceleration chu hilang am de ha. So it should be towards the center. So this is ar. Okay, constant speed ki pichula na hotela chun ar bow si am so at chu 0 tinai cho. Kutile a is along the plus I cap na plus I cap is so what is this a is that a here a to v square by r sana a to, so a is v square divided by r, so v square should have 4 into 4 divided by radius to 2 na ji chu bitang 2, 0 chu chila hebela chun chi, so this should be 2. Okay, so that means 16 by 2 is 8 meter per second square. Okay, so acceleration should be 8 meter per second plus I cap. Okay, so that it will be the answer. Okay, so here there is a mistake. So 4 z cap to 8 I cap hingai. Oh, so option A is the correct. Okay, so question is solved chu hesan chu hintin. So application in bolona. So theory I bol si chu lang pia question khalani iga apply ho jana I head ho chu. So application is previous question is solved pumana. Okay, kasai banga chu next video phale force ho isim de hoja. So we have done 2 videos already. Okay, hichipa he chanin ngauten na. Chahi acceleration to velocity lang pia bona I bolota chu. Akira khu centripetal force, centrifugal force kiti ho dynamics I bol deu na. Aban la khon achumble video chumble khala khu banking of roads ti ho I bol deu cha. So okay, I will stop here. Thank you for watching.